Okay, so we're going to look at expanding log expressions. And so when you're going to expand log expressions, basically you're going to be using the product rule, quotient rule, power rule. And so basically you're going to be going from a single logarithm to multiple logarithms, whether you're adding, subtracting, whatever it may be. But you're going from a single logarithm to more than one logarithm. So product rule, remember you're going from a log of a product to a sum. The quotient rule, you're going from the log of a quotient to a difference of two logarithms. Notice the numerator is the first one you see, the first argument. And then the power rule, basically you're going to take that power and you're going to write it as a product, as a coefficient times the log of m base b. Okay, so those are the three that you're going to see us use when we expand. So just remember expand, you're going from a single logarithm to more than one. Okay, and even though there's still one log here, when you have a product, you're expanding whenever you rewrite that exponent as a coefficient. Okay, so let's do number one. We're going to start off with an easy one. So let's look at the first one. So we have the log of u divided by v base 6. So notice that I want to expand this. So I want to go from a single logarithm to more than one. And so notice I'm taking the log of a quotient, right? So that's going to be the quotient rule I'm going to use. So the quotient rule says I can rewrite this as a difference of two logarithms. So this becomes the log of u base b, base 6. Don't forget your base, make sure you write the base, minus the log of v base 6. And there's your answer. That's all you do. Number 2, we have the log of 2x base, and notice I'm not putting a base here, but you got to remember that if you don't see a base, it's understood to be base 10. So one of the things you got to remember is this. One of the things you have to remember is that when you're dealing with the log of x and there's no base listed, that is your common logarithm. So that's defined to be our common logarithm. Common logarithm is base 10. So you're basically saying your base is 10. So these two, and if there's no base, if you don't see a base, it's understood to be base 10. You're also going to see this, the natural logarithm. So natural logarithm is where the base is e. Base is e, the number e. So that irrational number, that number e. And here's how it looks. So that'll be the natural log of x. You see that ln x. On your calculator, you see a ln button right here. That's a natural logarithm right here, ln. The one I'm pointing to right here, ln. So that's ln x. So whenever you see natural log x, ln x, that's your base e. That's understood to be base e. So ln x means log of x base e. Log x, log of x, means log of x base 10. All right, so natural common logarithm, natural logarithm. We're going to come back and talk about that as we go through this process. But let's go back to number 2. So number 2, I'm taking the log of a product, right? Well, according to our product rule, I can write as a sum. So I can expand. And go from a single logarithm to, in this case, 2 logarithms. So log of 2 plus the log of x. And there's your answer there. Number 3, I have the log base 4 of x to the 5th. All right, you may say, well, I don't see a quotient or a product being used here. You're right, you don't. But you do see this power rule that you can use. So whenever you have an exponent and you want to expand, you're going to take that exponent, you're going to write it as a coefficient. That's expanding. So this 5 right here, you're going to rewrite as a coefficient. So this becomes 5 times the log of x base 4. So that's all you do. Number 4, you have the log of the cube root of x base 5. So some of you may have a little bit difficulty with this one. That's because you may have forgotten how to deal with uh, cube roots, square roots, fourth roots, and so on, with radicals. You got to remember this from a previous course that whenever you have a radical notation, okay, looks something like this. Let's say the um, b root of x to the a power. You can always change radical notation to to rational notation, to rational notation, or exponent. You can always write as an exponent. All right, so by doing this, this becomes x to the a, your exponent here, a, divided by the index b. All right, so the b root of x to the a power, I can write as x to the a divided by b. Okay, so let's kind of talk about how to use it here then. So the cube root of x, then will be x to what power? X to what rational exponent? Well, my exponent right here is understood to be a 1, isn't it? And so my index is 3, so it becomes 1 divided by 3, so it becomes 1/3. If this is the fourth root of x to the third power, this will be x to what power? X to the 3 divided by 4. All right, so that's how you would write this. So to expand this, you want to rewrite this as a rational exponent. So basically, first thing you're going to do is going to say, well, that's be the log base 5 of x to the 1/3. And now I can use the power rule just like I did number 3. So the 1/3 I'm going to write in front. So that's how you can expand this with an exponent. So it becomes 1/3 times the log of x base 5. And so there's answer number 4. Number 5. So number 5, we have the log of x to the 4th divided by y squared. All right, now be a little bit careful. Some of you see this exponent right here. And so your first inclination is to use a power rule first. You cannot use a power rule first. The only time you can use a power rule first is if it looks like this, where you have the log of your argument being raised to a power. Notice though, my argument is this whole thing right here, right? That's your argument. So is this whole thing being raised to the 4th power? No. Is this whole thing being raised to the 2nd power? The 2nd power right here? No. So I have to use the quotient rule first. You have to use the quotient rule first. So this becomes the log of x to the 4th minus the log of y squared. So I have to use the quotient rule first. And now I can use the power rule. So I can use the power rule next, because I have x to the 4th power, so I can pull this 4 out in front, okay? And I can pull this 2 out in front. So our answer becomes 4 log of x minus 2 log of y. All right, so here, to go from here to here, I did the quotient rule first, okay? I cannot use the power rule first because the power rule only applies first if I have the log of the whole argument being raised to a power. And then to go from here to here, I use the power rule. Okay? All right, number 6. Number 6, let's suppose we have the log of base 5 of x, y to the 5th. The same thing. I cannot pull this 5 out in front because this whole thing is not being raised to the 5th power. See, it's got to be the log of this whole thing raised to that power. The only thing that's being raised to the 5th power is y, not x. So I've got to use the product rule first. The product rule first. So I can change this to an addition problem. So the product rule says if I want to expand a single logarithm, where I'm taking the log of a product, then I can write as a sum of 2 logs. So this becomes the log base 5 of x plus the log base 5 of y to the 5th. Notice, make sure you write the bases. If you leave the bases off, it's understood to be base 10. Remember that? So make sure you put the bases. So this is base 5. You got to say base 5. Now I can use the power rule here. So make sure you use the power rule. So this becomes a log of x base 5 plus 5 log of y base 5. Okay? So notice to expand this one, I use the product rule first, and then I use the power rule. Okay? All right, so that's number 6. Let's look at number 7. In number 7, we have this in number 7. Okay, so we have the log base 4 of x cubed y squared raised to the second power. So the log base 4 of x cubed y squared raised to the second power. So let's go back to our discussion like we did here. So remember, if you have the log of this whole thing raised to a power, you will do the power rule first, right? You'll do the power rule first, and that's what you have in it. Don't you have the power rule? So you see this whole thing being raised to an exponent, so you can do the power rule first. Now there's another way you can do this. We're going to do this in a little while, so I'm going to do this in both ways to show you the different approaches you could have taken with number 7. So to go from here to here, I'm going to use the power rule first. And for the power rule, I'm going to do this, I'm going to use the 2. So you're going to take this 2, and we're going to rewrite this over. So you have the log base 4 of x cubed y squared raised to the second power. So to go from here to here, I'm using the power rule. Okay? So that means I'm going to take this 2 and we'll pull out in front. So it becomes 2 log base 4 of x cubed y squared. And just like we talked about before, can you pull this 3 out in front and this 2 out in front? The answer is no, because the only way you can take this 3 and pull out in front is if this y was being raised to the third power, but it's not. So what we do now is use the product rule. So this becomes 2 log base 4 of x cubed plus, don't forget, it's still a 2 log base 4 of y squared. Okay? So go from here to here, I use the product rule. But notice I can expand it further, because what else can I also do? I can still use the power rule again, right? So I'm in this problem using the power rule twice. So I'm going to take this 3, I'm going to write it as a product. I'm going to take this 2, this exponent 2, I'm going to write as a product, a coefficient. But notice how this looks though. You have this 2 times this 3, don't you? Times the log of x base 4. Plus you have this 2 times this 2 times the log of y base 4. Now you can simplify this. 2 times 3 is 6. You get 6 log of x base 4. Plus, and then 2 times 2 is 4. You get 4 log of y. That's a y here. Base 4. And there's your answer. So you've expanded this problem into this. Now I want to remind you about number 7. We're going to do number 7 again. So log base 4 of x cubed y squared squared. So another way you could have done this is this way. So I'm going to cover the log expression right here, the log, the symbol log. And I want to remind you about this from a previous course. Do you remember that when you have these variables raised to an exponent and it's also raised to another exponent? Remember what this means? So x cubed y squared squared means x cubed y squared times itself, right? And so x cubed times x cubed is x to the 6th. Y squared times y squared is y to the 4th. So this right here is this. So what that means is I can rewrite this as log base 4 of x to the 6th, y to the 4th. And the other thing you can also remember from a previous course with this right here is this. Watch. X cubed y squared squared. So you can take x cubed raised to the second power, and you can take y squared and raised to the second power. So each of these is being raised to the second power. And remember, when you have a power raised to power, you multiply. 3 times 2 is 6. 2 times 2 is 4. So either way, you get the same thing. You get x to the 6th, y to the 4th. But look what's going to happen now. What you're going to do now. So here, I'm going to use the product rule first, and then I'll use the power rule. You can't do the power rule first because both of those don't have the same exponent. So you have to do the product rule first. So this becomes log base 4 of x to the 6th plus the log base 4 of y to the 4th. So to go from here to here, I use the product rule. Now I can use the power rule. So I'm going to take this exponent, put out in front. So this becomes 6 log of x base 4 plus 4, that's a 4, 4 log of y base 4. And notice this answer is the same as this one. But notice it for many of you, this was probably a lot easier to deal with than this one. But it doesn't matter, you get the same answer, but it helps to know multiple approaches you can take to problems. You just got to remember some things you've had in the past that will help you to be a little bit more efficient with some of these problems. Okay, that was number 7. So let's look at number 8. So in number 8, we have this problem. So we have the log of x divided by 10. Okay, now that's an easy one, but there's something you got to remember to do with this one. So watch closely. So first of all, you know you're going to use the quotient rule. So I'm going to expand this into the difference of two logarithms. And the quotient rule says a log of a quotient becomes the difference of two logs. So this becomes a log of x minus the log of 10. All right, now, you use the quotient rule. But here's something else you got to remember. And you had this in a previous lesson or worksheet. You have to simplify if possible. Meaning this. See this log of 10 right here? One of the things you learned when you first started talking about logarithms is how to simplify logs. What does taking the log of 10 mean? Now, these problems that you've done in the past were easy types. So basically what you did was we did this. So we said, well, let's see what the log of 10 equals. So I'm going to write this as a box, let's say. And then notice this, so it's an equation, right? So I can change this log equation to an exponential. You have to remember, if you don't see a base, that's a common logarithm. So that means the base is 10. So this is understood to be a 10 right here. So this becomes 10 to what power? Remember, change it to an exponential. 10 to what power is the argument? Well, 10 to what power is itself? Well, 10 to what power? 10 to the first, right? So this right here is 1. So the log of 10 is 1. And you can see on your calculator, watch. So if I take on my calculator, see here, see this log right here? That's base 10. The ln is base e. Remember base e? So you take log, and if I put 10 right here, notice what happens. You get 1. Log of 10 is 1. So the answer becomes log of x minus 1. That's your answer. So now you have to start thinking, well, can I simplify? And in some of these cases, you can. You will be able to, and you have to. So if you don't simplify when possible, you're not going to get all your points. All right, you'll get something from going from here to here because remember you did use the quotient rule, so you did something with it that was correct, but you didn't simplify all the way. So you got to simplify whenever possible. So let's do number 10. So number 10, let's suppose we had the log of 100x squared. The log of 100x squared. So just as before, you cannot use the power rule first because 100 is not being raised to the second power. So I have to use the product rule first. So this becomes a log of 100 plus the log of x squared. Now, here I can use the power rule, right? So this becomes a log of 100 plus 2 log of x. What some of you will do is you'll leave your answer like this, but you're not going to get full credit. You won't get full credit because just like with the log of 10, you can simplify the log of 100. Let's think about that, the log of 100. So remember, there's no base. If you, I keep saying no base, there is a base. If you don't see it, it's understood to be base 10. So the log of 100 equals some nice number. So you're gonna change this log equation to an exponential. So the base is understood to be 10. So you're gonna say 10 to what power is 100? Well, all of you know that 10 to what power is 100? 10 squared. 10 times 10 is 100, right? So this is 2 right here. So I get 2 plus 2 log x. Now be careful. Don't say 2 plus 2 is 4. Don't say this is 4 log x. That's not true. The answer is not 4 log x. So don't do that. The reason is because 2 plus 2 is 4. That's true, but that's not what you see. You don't see 2 plus 2. You see 2 plus 2 log x. These are not like terms. This has a log x in it. This does not. The only way that would have been a 4 log x if this would have said 2 log x plus 2 log x becomes 4 log x. But that's not what this is. So that is your answer. So don't forget, whenever you're able to simplify, you need to make sure you do that. Okay, let's do number 10. Number 10, we have the natural log. Remember, ln is natural log, that's base e. The natural log of e squared divided by 4. The natural log of e squared divided by 4. So let's go ahead and use the quotient rule first. You cannot do the power rule because this whole thing is not being raised to the second power. So you cannot pull this 2 out in front first. You got to use the quotient rule first. So this becomes the natural log of e to the second power minus the natural log of 4. All right, so you'll get points there. That's easy to have to figure it out. Now the next thing you got to do though is because you can expand this further, can't you? You can use the power rule now. So it becomes 2 natural log of e minus the natural log of 4. So now you get a few more points. But remember, you got to simplify whenever possible. So you got to recognize, see this ln e, the natural log of e, equal box. That's a nice number. So remember, ln, I can rewrite as, see this ln right here, I can write as log base e. ln means base e, means the logarithm base e. Your argument's e here. That's e, equal box. So now let's change this log equation to an exponential. So your base, which is e, raised to what number equals the argument, which is e. So e to what power is itself? Well, e to the first power is e. So the natural log of e is 1. So this right here is 1. So this becomes 2 times 1 minus the natural log of 4. 2 times 1 is 2, so you get 2 minus natural log of 4. And there's your answer. That's all you do. So you see this natural log of e? I want to show you in your calculator. So the natural log of e, right? So what? You're going to do this. Now you got to be careful. So you're going to press ln, natural log, but you got to get an e, right? So to get that e, you got to press second. Got to press second, and then ln. You see that e? But it's, remember, e is e to the first. So you got to put that 1, so that you're taking the natural log of e. Close that parentheses, close that one, and then watch what you get. You get 1. So the natural log of e is 1, and that's what we said. Okay. And then finally, number 11. So let's look at number 11. So in number 11, we have this. We have the log of 1,000 x to the 4th. The log of 1,000 x to the 4th. Now remember, see, you don't see a base. That's understood to be 10. I'm going to use the product rule first. So it becomes the log of 1,000 plus the log of x to the 4th. So just like the previous problem, I can also at this point use the power rule, right? The power rule. So I'm going to take this exponent right out in front. So that's expanding. Using the power rule is expanding. So I get the log of 1,000 plus 4 log of x. Again, you'll get most of your points, but you're not going to get all of it because now you got to figure out, If you leave it like this, you'll get most of your points. But see this log of 1,000? The log of 1,000? That's easy to figure out. So you see this log equation? The base is 10, right? So 10 to what power is 1,000? Well, 10 to the third power is 1,000. So that's 3. You also have to use your calculator. Watch. The log of 1,000. So log 1,000. Watch what you get. Equal 3. So the log of 1,000 is 3. Because 10 to the third power is 1,000. So this is 3. So I get 3 plus the log, 4 log x. And there's your answer. So again, just like before, don't say 7, because those are not like terms. Look at this, number 12, and then we'll stop at number 12. Let's suppose I had this. I had the log of, let's say, log base 2 of 8x to the third power. Okay? Log base 2 of 8x to the third power. So kind of like we did number 11, we can do the product rule first. So it'll be the log base 2 of 8 plus log base 2 of x cubed. All right? So all of you should write this part first. You'll get some points. Then you're going to also realize, hey, I can take this power. I can use a power rule. So I can take this exponent and write it in front, couldn't I? Okay, so you get the log of 8 base 2 plus 3 log of x base 2. All right. But the problem is, if you leave your answer like this, you're not going to get all your points, because you see this right here? Log of 8 base 2. You need to recognize that this right here means this. So what is this equal to? What is that equal to? Well, that means 2 to what power is 8? 2 to what power is 8? 2 to the third. So that's an easy one to figure out. So you need to say, well, that's 3. So that becomes 3 plus 3 log of x base 2. And it's kind of like saying this. Watch real quick. Suppose I had the log of log base 4 of, let's say, 16 divided by x. Okay? So I'm going to use the quotient rule first. So it becomes a log of 16 base 4 minus the log of x base 4, right? If you leave your answer like this, you're not going to get all your points, because you see this right here? The log of 16 base 4. You all know what that is. That's easy to figure out. 4 to what power is 16? 4 to the second power is 16. So that's 2. 4 to the second power is 16. So this becomes 2 minus the log of x base 4. So when you expand, just make sure you check and see if any of these can be simplified further. All right? So that is expanding. So now you know what expanding means. So expanding means to go from a single logarithm to more than one logarithm, except in this case where you still had a single logarithm, but expanding used the power rule. Okay? So that's expanding. So that should give you enough to get through that part of this topic.